If you've used a computer before, you've probably used 7-zip. And if you are using 7-zip and you're not using zoom in 2602, you are vulnerable to a pretty crazy bug. Guys, the world of getting file formats right is very hard, and it's a problem that we really haven't figured out. Now, I'm gonna be honest, when I started making this video and I was doing some research, I literally read this and I saw the XZ archive, or in a reference back to the Jaya Tan days of 2 years ago, and I had like a bit of a PTSD flashback. Guys, the vulnerability here is really interesting. You know, it's your classic something overflow because of a length value that does not get validated by the code and ultimately allows you to overflow and get control of the computer. And in this case, it has to do with a crafted XZ archive. Now, I did vibe code a little bit. I'm gonna be honest, your boy did some vibe coding, and I actually had to reproduce a POC that triggers the overflow here. I wanna go into what the actual bug is and why fuzzers that are actively fuzzing 7-zip right now didn't catch this. So if we go into the code here, right, we're gonna find this function called mix coder code. And I'm gonna be totally honest, as I was reading this code, it took me a while to figure out what the hell was going on. The variable names and function names in the 7-zip code base are a little confusing. Acknowledge that like 7-zip is maintained by a single person. That's very hard to do for a code base as big as 7-zip, but that doesn't matter for right now. Now this function exists inside of the XZ files, right? The XZ decoder files. XZ is basically a file format that 7-zip processes, and XZ itself can support a variety of compression algorithms, right? So in this case, we are using the LZMA compression format. What mix coder code is doing is it's taking a state object of the thing to be decompressed. And when you're doing LZMA, what you get are these things called filters, right? There's a variety of things you can add before and after the actual compression of LZMA to make it more efficient. One of them that's kind of cool actually is the BCJ filter. So if you're compressing like code, like actual like machine code, if there are hard-coded like either addresses or branch or call instructions, there are compressors based on the instruction set, so x86, PowerPC, etc., that'll make the compression more effective, right? It'll group those certain instructions together or change them to become more effective. Anyway, so you can specify in order, right, what order you want the filters to run inside of your XZ file for LZMA. Now, when the decompressors start up, right, we have kind of this state, right? We have an in buffer and an out buffer. We have this source and dest pointer, and we have two variables, source len and dest len. Now remember, we are doing multiple filters, right? So as we walk, what we should do is we run one filter on some of the data. The source len goes like this, and maybe we walk up the source a little bit, we go like this, and now source len is shrunk and source itself has been increased. The vulnerability here is when we do one filter run in this mode where there are multiple filters on an XZ LZMA stream, the source will move up, but the destination will move up without changing the value of destination length, right? So we basically tell the memcopy operation that copies the data out of the compression into the decompression like buffer. We say, hey, your destination is now here, but the amount of data you're allowed to copy out has not changed, right? And so by making a malformed XZ stream where the input and output data are generally the same, right? Low compressibility, like random data, and you run two filters on it, what you're able to do is force the decompressor to write data out of bounds in the heap, resulting in a heap overflow. I know a lot of that was very technical. I'm going to go show you guys the POC real quick. Again, the POC itself is just a Python script that generates this object. Or it's running a delta filter on the LZMA stream and the actual LZMA decompression stream itself. We're going to compress an object of just random data, ideally getting that data to be as random as possible so the decompression and the compression sizes are exactly the same. We're going to create the object headers here, and this is a bunch of like file format nonsense, but the end goal here is basically to be able to tell the LZMA input buffer that it's one size. When the mem copy occurs, it's actually a larger size that's 20 times larger, and we can get that overflow because the destination length that we're telling it about does not change. By the way, the actual bug in the code, I probably should talk about this before I talk about the actual POC. So basically, if we're doing, if we have an out buffer, which means we're not doing in-place decoding, we have two separate buffers for the actual decompression. We're gonna run the first coder, right? This is the first filter in the filter table, and then we're gonna look at the result, right? Now, if it failed, okay, it's finished, we move on. If the number of coders is equal to 1, then we're gonna set that destination length equal to destination length 2. We're gonna update the destination length, okay? However, if there are not just one coders, if there are two, and it was finished, then we can check that we do this code here. But the problem is we never actually enter this code block because the first coder sees that there are multiple filters going on inside of the filter table and doesn't report us as finished. We're not completed. So because of this, we get through this area, we're not finished, and we move on to the next part of the code where we run another filter, the second filter, but that destination length hasn't updated yet. Because of this, we run the second coder and that destination length 2 has not updated, even though dest2 has updated. If you're not following along, that's fine. This stuff is generally fairly complicated. It took me a very long time to understand this bug before I made this video. But what I'll show you is we're going to run GDB on 7ZZ. This is a version that I compiled. Then we're going to run an extraction on the, I believe it's in my home folder, 7-zip, what is it, finalpoc.exe. Yes, I want to replace the destination file, and you'll see we get a very nice SIG-SEG-V, which is the we're crashing structure, or the we're crashing signal, SIG-11. And the stack trace here that shows you all the functions that we're getting hit on the way up. We are inside of mixcoder code. We're doing the LZMA filter, the LZMA2 decoder, and then we're getting to a mem copy at the end where the length is copying the data outside of the bounds of our heap buffer because that destination length has not been updated to reflect. So very interesting stuff. Now, when I was making this video, I was like, wait, this is a pretty like trivial bug, right? This is literally just like, you know, we have a file format that hits an edge case and the edge case isn't coded properly. How did OSS-Fuzz not catch this? OSS-Fuzz, by the way, if you're not aware, is a Google project where basically a lot of open source code that is like very integral to the structure of the internet is being fuzzed in the cloud by Google. It is an open source project. You can go and look at the projects that are actively sitting in OSS-Fuzz. The idea here is if we just throw compute at projects with fuzzers being these things that programmatically or, you know, that randomly sort of look for bugs in code by throwing edge case data into the program and trying to find additional coverage, right? Trying to find edge cases of the program that were not originally thought through. And by doing this, the idea is that bugs fall out, we report the bugs, we get safer code. Now, if we look into the projects of OSS-Fuzz, there is an entry for LZMA. LZMA, I think, is supposed to represent 7-zip. And if we go to the actual lzmafuzz.git repo, we will notice a couple things, a couple of older files here, and then the most recent version, SDK23, I think, is also somewhere on the order of like 7 to 2 years old. So when I saw this, I was like, oh, okay, so we have it in OSS-Fuzz, but I don't think we're getting coverage on new code. Obviously, this is a hard problem, right? Because like every time you update your code, especially with Igor being the single guy maintaining this, you now have to depend on the open source community to go and like write harnesses for you to put them in OSS-Fuzz, and it's this whole very difficult process. That being said, if you're interested in fuzzing, two things you should derive from this. One, all because it's in OSS-Fuzz does not mean you're not going to find new bugs, right? You're probably going to find a ton of bugs because, you know, maintaining fuzzing infrastructure is hard. And two, if you want to get into open source, instead of like adding your name to a README and then adding a pull request, you can go try to help Google maintain their LZMA coding. I think part of the issue too is that like the 7-zip project itself is not actually maintained on GitHub. It's maintained on SourceForge. I think it's still a Subversion project. And then like there's somebody else that mirrors it to GitHub for Igor Pavlov. And so it's more of like a, you know, technology overlay, like compatibility issue than it is like a maintenance issue. Now you may be wondering, low level, why did you not demonstrate a full end-to-end exploit? Why didn't you actually hack it like a real hacker man? Guys, I am not going to do a heap overflow exploit for a video. The reason being, guys, like exploiting the modern glibc heap is like a huge pain in the ass. You can do it, but it takes like a bunch of like T-cache poisoning. I don't even know if that's still meta anymore. I think T-cache poisoning may have been fixed in like 2.3.8. I don't know. If you know what any of that meant, you probably know that like exploitation of the heap in modern glibc is very difficult. I could do this on like a Windows box potentially, but then I'd have to do Windows exploitation, and that's gross. Anyway, guys, thanks for watching. If you like this video, do me a favor, hit subscribe, please. We're trying to hit 10 million eventually. I don't know. And then go check out this video that I think you will enjoy. Similarly, it's about another 7-zip bug that I triaged a little bit in the past before one time.